All right, this is all about solving equations with rational exponents. So let's do several examples and I'll outline or demonstrate some common techniques. There's two common techniques. One is get a common base and then set the exponents equal to each other. The other is to solve by undoing, right? And knowing the context of when to choose which is kind of important here. Let's take this example. 4 to the 1/4 equals 16 to the x. Now the reason I want to solve this by getting a common base is I happen to notice that there is a common factor. 16 is 4 times 4. Right? So 16 can be written 4 to the second power. So let's rewrite 16 as 4 to the second power. 16 as 4 to the second power. So 4 to the second power to the x equals 4 to the 1/4. Note we could have also gone for a common base of 2. But now we're going to use the power of powers rule. 4 to the 2 to the x, power of powers, is 4 to the 2x. So 4 to the 1/4 equals 4 to the 2x. Now we've got a common base, same base, and the only way for exponential functions to equal each other is for their exponents to equal each other. So if 4 to the 1/4 equals 4 to the 2x, then 1/4 equals 2x. Okay? And now we just solve by undoing. Okay? So the opposite of times 2 is divide 2. Okay? A little scratch work. 1/4 divide 2. Keep the first and flip the second is 1/4 times 1/2 or 1/8. Okay? So 1/8. Another way to remember that, all that, is to say if I divide by 2, I multiply the denominator by 2. So to divide by 2, divide 1/4 by 2 is the same as to double the denominator 4. So x equals 1/8. All right? So that's the technique of getting a common base and then setting the exponent equal to each other. Let's do another example here. I'll leave this on the screen here. Let's go with green for a little variety. Number 2, here we go. 3 to the x over, I can't read, x over 3 plus 1. To the x over 3 plus 1 equals 9 to the 1/2. Okay? Again, noticing something, that 9 can be written as 3 times 3, or 9 is 3 times 3, or 3 squared. So replace 9 with 3 squared. 3 squared to the 1/2 equals 3 to the x over 3 plus 1. Now, power of powers, 3 to the 2 times 1/2, 2 times 1/2, multiply straight across, is 2 over 2, or 1. In other words, if I have 2 halves, I have a whole. So this is 3 to the 1. I'm going to write 1, you don't have to. 3 to the x divided by 3 plus 1. Now we've got the same base. 3 to something equals 3 to something. The only way for those to be equal is for their exponents to be equal. So x over 3 plus 1 equals 1. Let's subtract 1 from both sides. Got to do the same thing to both sides of the equation. X divided by 3 equals 0. Opposite of divide by 3 is multiply by 3. And 0 times 3 is 0. So x equals 0. Now I forgot to do something on the last example, and that was to check and make sure my solution works. I'll do that in this case. We can always plug in the value we got. So we can say 3 to the x divided by 3 plus 1 equals 9 to the 1/2, and we can substitute 0. Okay, and 0 divided by 3 is 0. 0 plus 1 is 1. This is 3 to the 1, or 3. And 9 to the 1/2 is the square root of 9, which is 3. So it checks. It does equal itself. Okay, so now, one more example. This example is going to be solved by undoing. So let me go to a new screen here. Okay. So I'm going to take 1/4 x to the, having trouble seeing, 3/5. 1/4 x to the 3/5. Need to get bifocals. Minus 12 equals -10. Now you notice here there's no opportunity to get a common base. The variable is in the base itself, right? So we're going to solve this by undoing. Think of it like peeling the layers off an onion. This is x to the 3rd power to the 1/5, which is the 5th root of that, times 1/4 minus 12. Take the last thing and do the opposite. The opposite of minus 12 is plus 12. So plus 12 to both sides, add 12 to both sides. We end up with 1/4 x to the 3/5 equals 2. Okay? Now we want to get rid of the 1/4. The opposite of times 1/4 is divide 1/4. Divide 1/4. Now to divide 1/4 is to multiply by 4. If I say how many fourths fit into something, I'm basically multiplying by 4. So we get x to the 3/5 equals 2 times 4, or 8. You can also think of it as multiplying by the reciprocal of 1/4, which is 4 over 1. Okay? Now here I differ from the book a little bit. I'm going to deal with the 3 first. So I'm going to take the 1/3 power, or the cube root of both sides. Okay? The 1/3 power, or raise it to the 1/3. Okay? In the book, they raised it to the power of 5/3, which reduces it down to one step, but I kind of prefer it this way. I think it's simpler to understand. So 1/3 of 3 is 1, so 3/5 times 1/3, the 3's cancel, or if you don't cancel, 3 over 15 reduced by 3, and you get 1/5 no matter how you work it. So this is x to the 1/5 equals the 3rd root of 8. Think what number times what number times what number equals 8. Well, let's break it down. 8 is 2 times 4, which is 2 times 2, so 2 times 2 times 2. So the 3rd root of 8, or 8 to the 1/3, is 2. Now we have to the 1/5 power, and the opposite of 1/5 power, if you think in terms of radicals again, this is the 5th root, right? The opposite of the 1/5 power is the 5th power. Okay, so we're going to multiply or raise both sides to the power of 5. Okay, think of it as this: 5 times 1 over 5, multiply straight across, is 5 over 5 is 1. Okay, so we have 2 to the 5th power, or x, equals 32. All right, and once again, let's check and make sure this works. Plug it in. 1/4 of x to to the 3/5 minus 12 equals negative 10, where x is 32. Okay, let's take the 5th root of 32, that's 2. 2 to the 3rd. 2 to the 3rd is 8. 1/4 of 8, or 8 divided by 4, is 2. 2 minus 12 is negative 10. So it does check. Okay. All right. I think that's about it. All the other examples are similar to these. Feel free to book a live lesson for any extra help. I know this is a tricky lesson.